Alright, this is Mr. Gillen. Today we're going to talk about squares and rhombi and some of their special characteristics. I'm sure you've been introduced to them before in the past, but we're going to actually formalize some of these things as theorems and things like that. Let's start with the rhombus. Basically, it's a parallelogram, so it has all the same properties of parallelograms as far as the opposite sides are congruent, diagonals are congruent, the diagonals bisect each other, all these things, except for there's one special thing about a rhombus that is special as compared to other parallelograms, and that is their diagonals actually intersect and form a 90-degree angle, which is huge for us because we know Pythagorean theorem and similar triangles, things, and all this stuff. A lot of that stuff, hypotenuse leg, all goes around that right triangle there. So if it's a rhombus, we know all these things. We know parallel, parallel, same length, same length, same length, same length. We know this guy is the same length as this guy. We know this is the same length as this guy. We know that this is a right angle. That's the new one. That's the big one right here. The right angle where they intersect at. That's the big one. And let's not get confused with our rectangle theorems. A rectangle's diagonals bisect each other, but they're actually congruent as well. On a rhombus, the diagonals are not congruent. That's only for rectangles. Okay, but the special thing about a rhombus is it intersects and it forms a 90-degree angle, which is huge. So let's take a look at some things about rhombi. It says if a parallelogram is a rhombus, each diagonal bisects a pair of opposite angles. So not only does it make a 90-degree angle on the middle here, this guy we know is 90 degrees. We also know that angle 5 and angle 6 are congruent, which also would mean angle 8 and angle 7 are congruent because those are alternate interior angles. And so we would know these guys are congruent because they're bisected, and we know 3 and 4 are congruent as well. So there's all kinds of these new properties with rhombi, especially about the angles that are new compared to rectangles or just other parallelograms. And so with the rhombi, the diagonals bisect each other and the angles. Additionally, the diagonals of a rhombus, FJ, HJ, intersect at K, and using given information to find each measure or value. So let's take a look what we know now. Remember, there's two things we just learned about a rhombus. I mean, when their diagonals intersect, they form a 90-degree angle. And we also know that their diagonals create equal angles on either side of the diagonal for each vertex. So in this case, it says measure angle FJH is 82, which would be this whole side right here. This whole angle would be 82 degrees. Find measure of angle KJH. Well, the new theorem we just learned, KHJ right here. Okay, so this is what we're looking for. We don't know how long that is or how big that is. We do know that 82 and 82 are the same on both sides. And if these are both 82 and 82, that is 164 degrees total, leaving how many degrees for the last two? 196 degrees for these two. Now I know that H and F must add up to 196, but I also know that they're congruent because it's a parallelogram and opposite angles are congruent. So if I divide 196 by 2, that'll tell me how much each one of them is worth, which would be 98. So I know all of angle F is 98 degrees. I know all of angle H is 98 degrees. Specifically because this is a rhombus, I know that this diagonal bisects each of these angles at each vertex. So I know that half of 98 would be 49, so therefore measure angle KHJ would equal 49 degrees. All right, so one more time. If I know this is 82, this is 82. Opposite angles of parallelograms are congruent. That leaves these two guys must be equal, and they're sharing 196 degrees, which is left over. So each of them must be 98, but a special property of a rhombus is that each of these angles is congruent. So I knew half of 98 would be my angle KHJ. So I'm going to go ahead and erase all that scratch work, that busy work there. I'm going to go on to the next part. It says if GH is x plus 9, and JH is 5x plus 2, or 5x minus 2, excuse me. Find x. I don't know if I mentioned this yet or not, but I just assumed that you knew. All rhombi have exactly 4 equal sides. Okay, it's a quadrilateral with 4 equal sides. So it's a little different than a rectangle, meaning I guess it's in the rectangle family. We're going to learn about that in a second. But rhombi and squares both have, and we're going to talk about squares in a second, 4 equal sides. So FG and JH are equal, as well as GH and FJ, but also every single side is the same length. So I guess that would be really important to tell you. If I haven't told you that, I don't remember if I mentioned it or not, but all sides of a rhombus are actually equal as well. So I can just make this one a quick solution here. 5x minus 2 must equal x plus 9 because all sides of a rhombus are congruent. And then we just solve algebraically, which I know we're getting pretty good at. Oops, got ahead of myself there. And divide by 4. And since we are talking about a length, we really do need to keep it as a mixed number or a decimal. I prefer the mixed number, please. X equals 2 3/4. Okay, that would be the distance. And since it is a distance, honestly, we should, I guess, now x is not a distance, but if I plugged x in, we would just have to say units. So we don't need to label the variable itself because the variable doesn't actually represent a distance. It represents a variable. So what we've got here is a nice little diagram here about the relationship between squares and rhombi and rectangles and how they all kind of fit together in the parallelogram universe. So here's the big parallelogram universe out here. All these parallelograms, but they're special types of parallelograms. There's the rectangles that have 4 right angles. But also with the rectangles, those are included, there's a subset of squares where they just happen to have 4 congruent sides. A rhombi is also a type of parallelogram as far as it has 2 sets of parallel sides, but it also has 4 congruent sides. And the square kind of fits into both the rhombus and the rectangle category because it meets the qualification of it has 4 right angles and it has 4 congruent sides. So there's kind of a little relationship. I'm going to bring this chart up again here in a minute. But let's go ahead and prove that this quadrilateral or rhombus is a square. So now we got a few little proofs here, little theorems. It says if the diagonals of a parallelogram are perpendicular, then it is a rhombus. So that's just literally the converse of what we just learned. If it is a 90-degree angle, then it is a rhombus. We said if it is a rhombus, then it is a 90-degree angle. So that's just the converse of what we just talked about. Okay, so there's not a lot more details to go in. If you can prove that that's a 90-degree angle between the two intersection of the diagonals, and you know for sure it's a rhombus. And similarly here, if one diagonal of a parallelogram bisects the pair of opposite angles, then the parallelogram is a rhombus. So if you know that this is equal to this, again, you know for sure it is a rhombus. So there's also, of course, this would be alternate interior with 1. So you could quickly find a lot of different angles on there just by knowing 1 if you knew it was a rhombus. But now we're saying the converse. If the angles are bisected on the opposites of the diagonals, then we know for sure that it's a rhombus. But it has to happen on both of them. Okay? Actually, I take that back. It has to happen on this guy. Its opposites need to be bisected, or if its opposites are bisected, one or the other, then it's guaranteed that it is a rhombus. Okay. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Okay, so if you just have a side-side relationship here where it's the same distance, same length, then you know for sure that that parallelogram is a rhombus. All right, it could be a square, it could be a rhombus, but it is a parallelogram for sure. Okay. So it only takes 2 sides of congruence that are next to each other to show that it is a rhombus. Okay. And then finally, this is a big one. If you can prove that it's both a rectangle and a rhombus, then it is a square. Okay, so it has to be both a rectangle and a rhombus. We got to prove that it has 4 right angles, and we also got to prove that it has 4 congruent sides. So on our proofs, they get a little lengthy because we have to prove so many things to show that it's a square, but that's all right. We can do it. This one says the key to the successful excavation of an archaeologist site is accurate mapping. How can archaeologists be sure that the region they have marked off is 1 meter by 1 meter square? Well, first of all, we need to know that's a square. Okay, so we need to know that there's 4 right angles. We also need to know that it has 4 equal lengths. So it looks to me like I have 1 meter here, 1 meter here, 1 meter here, 1 meter here. So we've met the qualification of every side is of equal length. We just need to meet the qualification that each of the corners is a right angle. Okay, so like I said, there's 2 qualifications it has to have. It has to be a rhombus, first of all, and we have met that criteria. We have two consecutive sides. In fact, we have all 4 sides that are given that they're all the same length. We just need to show that these are right angles here. If they can somehow show that, then we're good. What I would do is I would measure, if I was the archaeologist, if I just measured from B to D and I measured from C to A, and those are the same distances, I would know that it's also a rectangle. And then I would know that it's a rhombus because it has 4 equal sides, and I would know it's a rectangle because the diagonals are congruent. So first, show that it is a rhombus. And I can do that by 4 equal side lengths. In this instance, I could also do it several other ways, but in this case, I see 4 equal side lengths. And 2, if I had to show that it was a square, I know it would also, so this shows that it's a rhombus. Show it's a rectangle. I have to also show that it is a rectangle. And to do that, I would only have to do is, I would have to say, well, I just need to measure this diagonal from this diagonal. I need to measure distance from B to D and A to C if they are congruent. Okay, and so for that, as an archaeologist, I know that I have the 4 equal lengths here. That guarantees me a rhombus, but I just need to make sure the diagonals are congruent. Then it's my rectangle. So if it's a rectangle and a rhombus, boom, I know it's a square. Okay. And finally, a coordinate geometry. I know you like these coordinate problems. It says determine whether the parallelogram JKLM with these vertices is a rhombus, rectangle, or a square. List all that apply and explain. Well, to show that it's a rectangle, what I would do is, since we know it's a parallelogram, I would find the distance between J and L. Okay, so the things that we would have to do is, 1, show JL is equal to KM. Okay, show those segments are equal. That guarantees me it would be a rectangle. All right. We already know it's a parallelogram, so we know the slopes of the opposite sides are already parallel. The next thing I would need to do is I would need to see if it's a, we could check for if it's a rhombus. We would have to know that the slope of these is perpendicular to one another. And so this will be the first time that I think we talked about perpendicular slopes. We know about parallel slopes are the same. Perpendicular slopes are opposite reciprocal. So for instance, if I had a slope of say 3/4, its perpendicular slope would equal -4/3. Okay, and so I would have to show, for it to be a rhombus, show slopes are opposite reciprocals. Okay, if the following 2 satisfied, then I would know for sure that the parallelogram itself is a square. So if 1 and 2 happen, then parallelogram JKLM is a square. Okay, now I'm not going to work all that out for you because I know we know the distance formula. I know you can do these things. But these are the 2 things that have to happen. So the diagonals would be opposite reciprocal slopes. If they're perpendicular, that would guarantee me this right angle for the rhombus. And also I would know for a rectangle that these diagonals would actually have to be the same length as well. We know from the little chart here that if it's a rectangle and a rhombus, then we know for sure it is a square. So it can only be a square if it fits both 1 and 2. And that's it for today.